Okay, so we're going to see what a Wheatstone bridge is used for. And let's go ahead and just first get the idea. What does it do? So let's say we have a circuit like this. Okay. And then we have a resistor here, and a resistor here, and then a resistor here, and then a resistor here. Okay. Now, this circuit here, we would like to put also an ammeter here. So I'm going to put a galvanometer, and I will explain in a minute what it can do. Now, let's call this one R1, R2, R3, and we're going to call this one RX. And you know what? R3, I'm going to make it a potentiometer. So that means I can tweak it to change some values for R3. Now, here's the point. The point of this is you need to know first, what are the values of R1 and R2? What you want out of this is a ratio of R1 over R2. Okay, so let me just write it up here. R1 over R2 as a ratio. We'll get to see this. What does it mean? Okay, and the point of all of this is, let's say we have an RX that we don't know X. We don't know this value. We don't know this resistor, right? We're given a resistor with no color bands, and we're supposed to find it. Okay. A circuit like this typically allows you to configure that value based on this circuit configuration. All right, so the idea behind it is that this ratio R1 over R2 will eventually be equal to R3 over Rx if the circuit is balanced. And what is a balanced circuit? A balanced circuit means the current in this branch right here will be 0 amp. All right, so if you have a galvanometer, right, so it has a hand here, and it can swing either way, right? Negative, positive, depending on the direction of the current, right? And or if you have a digital ammeter, okay, you might get negative or positive values out of the ammeter put in this location right here. So negative will indicate the current is going one direction, positive is going the other. Ultimately, we want 0 amp and this one right into the center of a galvanometer, right? Or an analog ammeter, if you will, to make sure that, hey, you know, we've tweaked R3 enough, okay, since it's a potentiometer, to where we have no more current in this branch. Now, we figure out, okay, well, what is the value of R3? What did we get it to? Once we know that, then we can deduce from this, we can take this, and we could say, yeah, you know, R1 Rx equals R3 R2, which means Rx will be equal to R3, the value that you're looking for, or I'm sorry, the value that you find divided by R1. Hence, that will give you the Rx. So, in real world, what happened is these typically are decade resistors. So if you go to older labs, you might see some boxes set up this way with dials, right? Okay, and you could set it up for maybe by the units. So this would be ohms, tens of ohms, hundreds of ohms, kilo ohms, etc., etc. Okay, and you set them all to 0 to start, and then you start tweaking your dials and watch the galvanometer here swing one way or the other, depending if the current is heading this way or that way. Obviously, when it gets to 0 amp, right, you want the galvanometer to be right in the middle. And usually there's an indicator there for the center 0, right? And you get your negative here, your positive here, right? Same thing with, you could use a digital ammeter if you want, okay? Once you have that, then you collect the value, this here from the decade box, and that would be your R3, okay? And then you plug that into the formula here to find what your Rx is. That's the whole point of using this bridge right here.